Hi again, and welcome to our third section in this chapter where we're continuing to talk about general angles, but in this section we're going to talk about how to find the trig functions of any angle. In section 1, we talked about finding trig functions, sine, cosine, tangent, cosecant, secant, cotangent, for acute angles inside of right triangles. So in this section we're expanding that idea. In the last section we talked about angles of all sizes, we talked about radians and degrees. So now we're going to take that information and we're going to find the actual values of trig functions, sine, cosine, tangent, cosecant, secant, cotangent, for general angles. And we're going to talk about it in two ways. General angles where I know a point on the angle on the terminal side, and I'm going to talk about another way to do it using reference angles. So in this section, there are only two main vocab words that you need to focus on, quadrantal angle and reference angle. The rest should be review. All right, this first one, it's super important you distinguish the two different things we're going to do today. This first way to find trig functions of general angles happens when I know a point on the terminal side of my angle. So if I know an xy point on the terminal side of my angle, these 6 ratios represent the 6 trig functions for this angle. So if my point xy is on the terminal side, I use the Pythagorean theorem to find out how long r would be from the center to that point on the terminal side, so from 0, 0 to that point. So if I use the Pythagorean theorem, I end up with this relationship. R is the square root of the quantity x squared plus y squared. Then sine of theta is always y over r. Cosine of theta is always x over r. Tangent is y over x. Obviously, x can't be 0. Cosecant is just the reciprocal of sine, r over y. Secant is r over x, and cotangent is x over y. So make sure you keep this chart as reference. You'll need it when we practice in class. And you will need to memorize these ratios. So r, remember that r is always going to be positive. So whether or not sine, cosine, tangent, cosecant, secant, cotangent are positive or negative depends on the x's and the y's and which quadrant they're in. So here we have an angle theta. Its terminal side goes through the point 8, negative 15. So I'm going to find the exact values of the 6 trig functions. So from this coordinate, I know that x is 8 and y is negative 15. So now I need to find r. R is the square root of the quantity x squared plus y squared. So I just plug in 8 squared plus the quantity negative 15 squared. And when I do that, I get the square root of 289, which is 17. So this is now my r value. R is 17. And now sine is y over r, so negative 15 over 17. Cosine is 8 over 17, positive. Tangent is negative 15 over 8. And then cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So notice, if we go back and look at the picture, that the terminal side of this angle is in the 4th quadrant, right? So in this quadrant, x is positive and y is negative. So that affects the fact that sine is negative, cosine is positive, tangent is negative. Okay, so pay attention to that. It's going to come back later. So you guys try and get the 6 trig values for an angle whose terminal side contains this point. All right, the answer here should be A. Those are the 6 trig functions. You should have gotten an r value of 5 as I'm showing here. So in this case, sine is y 4 over r 5, and so on. Okay. If the terminal side of my angle is not inside of a quadrant, but it's on the x or y axis, we call it a quadrantal angle. All right, and these are pretty easy to find, sine, cosine, tangent, and all of that for, because we always just have to think about the point that they go through. So if I have a 0-degree angle, so it hasn't opened up at all, its terminal side is on the x-axis, I think about the fact that it goes through some x value, and the y value is 0. If I have, and the x value here is going to be equal to r, right? Because r is the distance from the center to the point, so it's going to be the same as my x value. So in this case, my x value is r. If it's on the y-axis at 90 degrees, this point is 0, r. So whatever the distance is from the center to that point. If it's 180, it's negative r, because x is negative. Negative r 0, and if it's at 270 degrees, or 3 pi over 2 radians, it's 0 negative r. So in this case, the terminal side of theta contains the point 0, negative 2. So if we think about what that looks like on a graph, just a quick sketch, 0, negative 2, it's right here. So that means my initial side is this. My terminal side is here on the negative y-axis. So I'm talking about a 270-degree angle. And that distance from the center to that point is 2. So in this case, r equals 2, x equals 0, and y equals negative 2. So we're going to write all of our trig functions. Oh, here, they drew it for us a lot more beautifully. So this is the r value, which is 2, because that's the distance from the center to the point. X is 0, y is negative 2, and we do the exact same thing that we just did. Sine is y over r, so negative 2 over 2, which is negative 1. Cosine is 0, x over r. And notice what happens with tangent. Tangent is y over x, but since x is 0, negative 2 over 0 is undefined. So 270 degrees, or 3 pi over 2 radians, does not have a defined tangent value. Cosecant is negative 1. Secant is undefined. Remember, secant is the reciprocal of cosine. Since cosine is 0 over 2, secant is 2 over 0, which is also undefined. And then cotangent is 0 over negative 2, x over y. So that's 0, and that's fine. All right, so you guys try with this example. All right, in this case, you should have gotten A. The sine of theta is 1. And hopefully you read carefully, and they were asking you which one of these answers is incorrect. In this case, it's sine. Sine would be y over r. In this case, r is 3, x is 3, and y is 0. Since the sine ratio is y over r, I get 0 over 3, which is 0. So the sine of theta is not equal to 1, it's equal to 0. Okay, so all of that we just talked about is when I know a point on the terminal side of my angle. In the second part of this section, we do not know a point. Okay, so you have to keep those two different procedures separate. In this case, we're going to use something called a reference angle, since we don't know a point on the terminal side. The reference angle is the acute angle formed by the terminal side of theta and the x-axis. So if my angle is in the first quadrant, I don't have to worry about it. It's an acute angle. We're going to be able to find the trig value of that angle with no problem. So basically, the reference angle is the angle. If my angle ends in quadrant 2, this is my actual angle, right? The reference angle is the distance or the angle measured from the terminal side to the x-axis. It's an acute angle. So my reference angle is right here. In quadrant 3, this is my angle that goes all the way around into the third quadrant. My reference angle, again, I'm always measuring to the x-axis. So my reference angle is always measured to the x-axis. So this would be my reference angle. And in the fourth quadrant, I come all the way around over to here. My reference angle would be this angle right here. We call it theta prime. My reference angle is the acute angle from the terminal side to the x-axis. So what we're going to do here is sketch an angle that's 330 degrees, and we're going to find its reference angle. So I sketch 330 degrees. It's almost all the way around, right? So this is my 330 degree angle. The reference angle is this angle right here, the acute angle from the terminal side to the x-axis. If it's 330 degrees to get to the terminal side, this angle right here has to be 30 degrees. 360 degrees minus 330 degrees gives me 30 degrees. So the reference angle here is 30 degrees. All right, let's do one in radians. So here I have the angle negative 5 pi over 6. You guys should be sketching these in your notes. Negative 5 pi over 6 is the same as 7 pi over 6. Sorry, they have a typo there. It's not 2 pi equals. If I take 2 pi, or 1 whole revolution, minus 5 pi over 6, 7 pi over 6 would be coterminal, but negative 5 pi over 6, remember pi over 6 is 30 degrees. 5 times 30 degrees is 150 degrees. So this is negative 150 degrees. So I end up in the third quadrant. So my reference angle is this acute angle from the terminal side of my angle to the x-axis. Notice this whole thing, or this half circle right here, right? That's pi. So if I take pi minus 5 pi over 6, because I want to know what this leftover bit is here, using our fraction knowledge, that's 6 pi over 6 minus 5 pi over 6. That means that pi over 6 must be my reference angle. If you think of it in degrees, we just said negative 5 pi over 6 is negative 150 degrees. So that's 30 degrees that has to be right here. And in radians, 30 degrees is pi over 6. Okay, I want you guys to try this one. All right, your reference angle here should be 45 degrees. Here's what your sketch could look like. Again, this angle right here is my 45 degree angle, the reference angle. And this one. Okay, negative 3 pi over 4 ends up again in the third quadrant. So here my reference angle would be pi over 4. Ooh, that didn't turn out very nice. Pi over 4. All right, what we are going to use these reference angles for, so far we just talked about how to find them. What we use them for is to evaluate trig functions. So again, if I do not know a point on the terminal side, so I don't know an xy point, I can use reference angles to find sine, cosine, and tangent. You have to pay very close attention to the signs. So in the first quadrant, x and y are both positive, so everything is positive. Sine, cosine, tangent, cosecant, secant, cotangent. In the second quadrant, since x is negative, that makes cosine and tangent also negative, but sine stays positive. In the third quadrant, x and y are both negative, so that makes sine and cosine negative, but tangent is positive. And in the fourth quadrant, since x is positive and y is negative, sine and tangent and their reciprocals are negative, but cosine is positive. So you have to think about that. Our steps for finding trig functions with reference angles: step 1, find the reference angle. Step 2, again, remember theta prime is the reference angle. So I find sine, cosine, or tangent for the reference angle. And then I'm going to figure out if it's positive or negative, and that's going to give me the correct trig function for theta. The cool thing is that the trig function for the reference angle is almost the same as the trig function for theta. The only way it'll be different is by a positive or a negative. You are going for this part to need to know the trig functions for the basic angles, 30, 45, 60, and 90 degrees. We will not get away from these. You need to know them in degrees and radians, and you should start knowing or memorizing their different trig functions. So the sine of 30 degrees is 1/2. The tangent of 45 degrees is 1, and so on. Remember, if you get stuck, you can use special right triangles. There is a chart like this in your book if you need it for reference right now. All right, so we're going to find the exact value of the sine of 135 degrees. That means we are not going to plug it into the calculator. We are doing this by hand. So if I sketch my 135 degree angle, it looks like this. Its terminal side is in quadrant 2. So its reference angle is 45 degrees. Again, the reference angle is that acute angle from the terminal side to the x-axis. So step 1 was to find theta prime, or my reference angle, 45 degrees. Step 2, I'm going to find the sine of 45 degrees. And you're thinking, well, it's 135. Hang on. The sine of 45 degrees, again, if you go back and look at your chart, or you should be memorizing it, is the square root of 2 over 2. So the sine of 45 degrees is the square root of 2 over 2. 3, the sine of 135 degrees, it's going to be the square root of 2 over 2, but I have to figure out if it's going to be positive or negative. Since I'm in the second quadrant, I know in the second quadrant, sine, remember sine is y over r. Y is positive in this quadrant, and r is positive, so this is going to be a positive square root of 2 over 2. All right, now we're going to do the same thing with cotangent of 7 pi over 3. If we sketch our angle, the terminal side is in the first quadrant. That means my reference angle here is going to be pi over 3, the distance from the terminal side to the x-axis. Pi over 3, if I'm finding the cotangent, remember that pi over 3 is 60 degrees, so I'm finding the cotangent of 60 degrees. If I look at my chart again, or use special right triangles, that's the square root of 3 over 3. And since I'm in the first quadrant, everything is positive, so these are going to be equal to each other. The cotangent of 7 pi over 3 equals the cotangent of pi over 3. All right, last one.